Hello students, welcome to Learn Guru classes. So today we are going to start a new topic under the first chapter real numbers, that is Fundamental Theory of Arithmetic. So this particular topic will be divided into three segments. So the first segment will be about basic concepts of Fundamental Theory of Arithmetic like prime numbers, composite numbers. The second segment will be concentrated on basics of HCF and LCM and how to find out HCF and LCM using prime factorization, and the third segment will be based on the HCF and LCM word problems. So today's video is all about simple basic concepts about Fundamental Theorem of Arithmetic, which will be a very short video. Okay, so I assure you that after watching this video, your concepts about this topic will be very clear. So with this note, let's begin our class. Before understanding Fundamental Theory of Arithmetic, you should know what are prime numbers and composite numbers, which I am sure you have already studied in your lower classes. The prime numbers are those natural numbers which are divisible by 1 and the number itself. That is, they have only two factors, that is 1 and the number. So let's take some examples of prime numbers like 11, 13, 23, 29 and 31. So the factors of 11 are 1 and 11. Factors of 13 are 1 and 13. Factors of 23 are 1 and 23. Factors of 29 are 1 and 29, and the factors of 31 are 1 and 31. So we see that only two factors are there in prime numbers, that is, they are divisible by only these two numbers. On the other hand, composite numbers are those numbers that are divisible, that have more than two factors. Let's take some examples of composite numbers like 6, 12, 32. So the factors of 6 are 1, 2, 3 and 6. Factors of 12 are 1, 2, 3, 4, 6 and 12, and the factors of 32 are 1, 2, 4, 8, 16 and 32. So we can say that other than 1 and the number itself, it has more factors. So these type of numbers are called as composite numbers. Let's come to the main topic, that is Fundamental Theory of Arithmetic. So the theorem states that every composite number can be expressed as a product of prime except for the order in which this prime factor occurs. So to analyze it, let's try to understand this theorem with the help of some examples. Let's try to understand the Fundamental Theory of Arithmetic with the help of some problems. So the first one is 105. Okay, so let's find out the factors of 105 with the help of factorization. So 105 is a number that is divisible by 5. So 2, 1. So 21, again we can write 3 into 7 is 21. So the factors of 105 are 5 into 3 into 7. So what are these numbers? These numbers are prime numbers, and 105 we can call it as a composite number because since it has three factors. Okay, so we can say that any composite number can be expressed as a product of prime numbers irrespective of the order in which the prime factor occurs. Like here I have given the sequences 5, 3 and 7, or now I can give the order as 3 into 5 into 7 or 7 into 5 into 3 irrespective of the order of the prime numbers. Okay, we can express a composite number as product of the prime numbers. So this is the fundamental theorem of arithmetic. So the second problem is 462. So let's find out the factors of 462. So this is 231. So 231 is a number that is not divisible by 2, but it is divisible by 3. So 3 sevens are 21. So we get 1. So this is 77. So 77 is again divisible by 7. So we can write 462 as 2 into 3 into 7 into 11. The third sum is 651. So 651 is a number that is divisible by 3. So let's check. 651 divisible by 3. 3 2 is 6. 3 21 217. 217. And this is, so 217 is a number that is divisible by 7. 7 3s are 21, 7 1s are 7. So 651 can be written as 3 into 7 into 31. So 3 is a prime number, 7 is a prime number, and 31 is also a prime number. So let's check the fourth sum, 429. So 429. Let's find out the factors. So it is a number that is divisible by 3. So 429, 3. 3 1s are 3, 12. 3 4s are 12. 3 3s are 9. So 143. So 143. If I check 143, so 3 4s are 12. So 343 can be divisible by 3. So let's check it with 11. So 11, let's check 11, 143, 11 1s are 11, 33, 13. So we can write 429 as 3 into 11 into 13. Let's check the fifth sum, 5005. So 5005, we can say that the factor 5 is the factor. So 1001. So 1001, let's check whether it is divisible by 7 or not. So 7 1s are 7, 30. 7 4s are 28, 21. So 7, it is divisible by 7. So we get as 143. So 143 can again be divisible by 11. So we get the ultimate answer as 13. So 5005, we can write the factors of 5005 as 5 into 7 into 11 into 13. So thus we say that any composite number, all these examples are composite numbers because they have factors more than 2, as well as these composite numbers can be expressed as a product of the prime factors. So the second example is simplify each of the following and show that the resultant is a composite number. So you have to simplify this expression, these complex expressions, and after that you have to show that the result that is coming out is a composite number. So how to express a number as a composite number? To show that the factors that is more than 2 factors. So if we can show that these expressions have more than 2 factors, then we can say that the result is a composite number. So let's get started. So the first example is 5 into 11 into 13 plus 13. So we can take here 13 as common. So we are getting 5 into 11 plus 1. So 5 into 11 is 55 plus 1, that is 13 into 56. So 56 can again be expressed as 13 into 7 into 8. So we can say that from this we have derived 3 factors of this expression. So we can say that this is a composite number. So since there are 3 prime factors, therefore the result is a composite number. Okay, so let's check the second sum. Second sum is 6 into 5 into 4 into 3 into 2 into 1 plus 5. So let's check in both these two terms. One thing that is common, that is 5. So let's take 5 as common and we can write it as 6 into 4 into 3 into 2 into 1 plus 1. So here 6 into 4 is 24. 24 into 3 is, let's check, 24 into 3 is 72. 72 into 2 is 144. So 144 plus 1 gives us 145. Okay. So now 145 can again be broken into further factors. So let's factorize 145. So 145 is divisible by 5. So 5 2s are 10. So this comes as 29. So we can write this as 5 into 5 into 29. So how many? So 5 is a prime number. These two 5 is prime number and 29 is also a prime number. So 3 factors are there. So since there are 3 prime factors, therefore the result is a composite number. We have come to the end of this video, where this video was very short, where some basics about prime numbers and composite numbers, the theorem and some numericals based on this topic have been discussed. So the next video or the next segment of this topic will be on some fundamental or basics of HCF and LCM and how to solve HCF and LCM using prime factorization. So for this you have to stay tuned to this channel. So if you find today's video helpful, please subscribe to Learn Guru classes, like, comment and share it with your friends and relatives. So thank you so much. Bye-bye.